Alright, let's take a look at graphing equations 1. Now, if I give you an equation and you need to graph it, last time we talked about using a table. We can always use a table to graph with. Okay, we can always do that. So I could take this graph and I could plug in -1. So 2 times -1 plus y equals -5 would give us -2 plus y equals -5. Add 2 to get it to the other side. Those would cancel. We'd be left with y equals -5 plus 2 is -3. We plug it in as 0. 2 times 0 plus y equals -5. That would just eliminate and we get y equals -5. Now if we did it for a positive one, same process. 2 times 1 is 2 plus y equals -5. Subtract 2 this time, we'd end up with -7. We can see the pattern here that we're subtracting 2 each time. You can see the pattern here that we're adding 1 each time. Okay, so we could then plot those points. -1, -3, 0, -5, and 1, -7 would be right about there. And then you could draw your line, draw your arrows, and you could graph it that way. Now, we can do that, or we can talk about the way that we learned how to graph, which is using the slope-intercept form, which we call y equals mx plus b. M is your slope, slope meaning how does the y values change over the x values, and the b, which is your y-intercept, which is where it crosses the y-axis. Problem is, this equation isn't set up to use this format, because the y has to be by itself. However, I can make it that way. To get y by itself, I can just subtract a 2x from both sides. That would give me 0 still. Y equals -5 minus 2x. I can't combine them because the 5 doesn't have the x and the 2 does. So I rewrite it as -2x minus 5. Okay. Then the first thing you do is you find the y-intercept. The y-intercept is the number right here, the b, the number not with an x. So my y-intercept is -5. So I go on the y-axis, the vertical one, down to -5 and draw my point. Notice, same thing, right? Same thing. Okay. The next step is then to find that slope. Okay. The slope is the number with the x, so it's -2. Now slope is y over x, so make it a fraction. Put a 1 under it. So it's like y over x, rise over run, -2 over 1. What that means is, for every time we go horizontally 1, we're going down 2. Okay? You can see those numbers pop up in our table as well. So the top number tells us to either go up or down, the bottom to the right. So negative means we go down, positive means we go up. So I'd go down 2, 1, 2 to the right 1. Draw my next point. And I could go down 2 and to the right 1 and keep going that way. Or I can think about it that negative as with the 1. Because on a fraction you can change the negative to the bottom or the top. If I do it that way, I'm thinking of a positive taking me up, a negative taking me to the left. So I'd go up 2 and to the left 1, up 2 to the left 1. And I could keep going with that. So notice, either way I do it, I get the same answer. So you can always use a table of values, or you can use the slope-intercept form. For the rest of the problems, I'm just going to focus on that slope-intercept form. So we've got y equals -x plus 3. Remember slope-intercept form. M is our slope. B is our y-intercept. Our equation is y equals -x plus 3. So where's our y-intercept? It's right there. B equals 3. I go to the y-axis, up to +3, draw a point. That's my starting point. Now, if I look at x, there's no number there, right? Wrong. If you remember the multiplicative identity property of 1 tells me I can multiply by 1 without changing it. So I can put a 1 there. So my slope is negative 1. To make it a fraction, put a 1 under it. So I can go down 1 and to the right 1. Down because it's negative, to the right because that one's positive. So down 1 and to the right 1, down 1 and to the right 1, down 1 and to the right 1, and I can just keep going with that same pattern. And if I really wanted to, I could go the other way with that pattern. I could make it 1 over negative 1. Then it would be up and to the left. Up 1 to the left 1. Up 1 to the left 1. Until I get my lines. Then remember, we always connect the dots, go beyond them, and draw an arrow, because equations don't stop. Not the ones we're dealing with anyway. Okay? So it's as simple as that. Okay, what about if you're already given the fraction? Now notice their negative is in the middle, which means I either keep it up top or put it down bottom. But my y-intercept is 1. Okay, it's the one not with x, so I go up to positive 1, draw my point. My slope is a negative 2/3, or 2 over negative 3. Either way, it's going to give me that same pattern. So I go either down and to the right, or up and to the left. Okay, down and to the right would take me down 2, 1, 2, to the right 3, 1, 2, 3. Draw my next point. Down 2, 1, 2, to the right 3, 1, 2, 3. Draw my next point. All you need is 3 points, and then you can draw your line. If I decided to go with the other one, I would go up 2, 1, 2, to the left 3, 1, 2, 3. Draw my point. Up 2, 1, 2, to the left 3, 1, 2, 3. Draw my point. Now I did more than 3, but you only need to do 3. Draw my line. Notice that my slope gives me that kind of staircase pattern. As long as I'm doing that pattern, I can go either way. Also, something to notice, all of these ones have been negative slopes. As I look left to right, notice that they're going down. Left to right, notice it's going down. Left to right, notice it's going down. Those are negative slopes. If you have a negative slope and yours is going up, you're doing it wrong. Okay. Whereas look at 8. Okay. It's got a positive slope. So a positive slope should be the opposite, and it should be going up like that somehow. But let's take a look at it. So, now if you look at this, you may say, well, that doesn't look like the slope-intercept form. There's no b. Now remember, back to that additive identity property of 0 says we can always add a 0 and take it off. So there you go. So my y-intercept is 0. So I draw it right there. Okay. Now my slope is a positive 3/4. So positive and a positive means up and to the right, or if I'm thinking about it backwards, it would be like a negative over a negative, because 2 negatives make a positive, and it'd be down and to the left. Okay? So, positive up 3, 1, 2, 3, to the right 4, 1, 2, 3, 4. Draw my point. And I could go up 3 and to the right 4 again. Or I could go the opposite way and go down 3, 1, 2, 3, to the left 4, 1, 2, 3, 4. Notice despite going down and to the left, I'm still maintaining, as I look left to right, I'm still maintaining that positive slope. Okay? And there we go.